At Service Logic, we believe the future of the skilled trades lies in training and development. And that's why we created The Edge, a platform dedicated to empowering our greatest assets, our people. From hands-on training to leadership development, Edge is where technicians grow their skills, expand their opportunities, and build lasting careers. Because when people succeed, our companies, our customers, and our industry thrive. This is The Edge. This is the future of the skilled trades.
I chose iConnect training equipment because I already previously had some iConnect training equipment. And I was very pleased with the equipment I had, the quality of it, and pre-designed labs that came with it. So when I expanded it more into the catalog, I decided I wanted to get this refrigeration trainer in my program to expand my program. My experience so far using the TU-155 has been pretty good experience, especially my second year students. And the light bulb kind of syndrome goes off when you see that little flicker in their eye and they're, oh, I got it. That's what us instructors, what we look for is the I got it moment. And this helps me to the I got it moment with my students, and that's what's my goal to achieve.
We are Daikin, the #1 global indoor comfort provider. Our innovative home and building solutions are engineered with energy efficiency and sustainability at their core, ensuring improved indoor air quality for all. From heating and cooling to ventilation, air purification, refrigeration technologies, and connected devices, we're at the forefront of technology, addressing the pressing challenges of sustainability.
Well, hello, everyone. Thank you all so much for joining us on Did You Know, the ESCO HVAC show. So we are now settled into the new studio. We're getting all of our cameras organized. We're starting to get all of the audio and video trimmed out. It's been so much fun. We're already here. I'll share a little bit of videos. We'll move over to an additional video feed so you can see what we've got going on. Jocelyn and I had a lot of fun last week doing the first test run with things, and now it's moving into a whole different realm where we can actually start using all of these products. We can start bringing some training into the classroom, and so we'll have a variety of different shots that we'll be able to use in here from all three of the different primary cameras. We're going to have additional cams too, as we start working with different products. Wow, that's weird seeing yourself in two different cameras. All right, so we are going to spend a little bit of time today talking about something that I absolutely love talking about. We're going to dive deeper into communicating HVAC systems and the protocols that go along with that. Jocelyn is joining us remote. She's going to be keeping an eye on the chat. So let us know in the chat where you're joining from. Grateful to have you here. I am sitting in the middle of a parking lot at our storage facility here in Brownsburg. Hey, Tom, thanks for joining us. And it's amazing what we can do with technology. That's why we spend so much time here at ESCO is, talking about the things that are changing in the industry and the world around us. So think about this. I am sitting in this mobile studio right now. I just finished installing our ductless system yesterday. So one of our primary sponsors, Daikin Comfort Technologies, has generously provided our cold climate heat pump. So I have got the heat pump cranking right now. I've got all of our computers. I have all of our lighting. And we're just sitting here off from a solar panel and some batteries. Isn't that amazing? And Kendrick, thanks for joining us in Chicago. So we're gonna dive deep into some technology. And Joseph, how are you doing today?
Hey, Clifton. Hi, Jocelyn. It's great to see you guys.
Hey.
Joseph is with Allied Air Enterprises, and we met at the 2025 Allied Conference just not very long ago, a few weeks back.
Yeah,
And
right about a month now, I guess.
it's been about a month, yeah. And so anyone that has seen the amazing Allied Air podcasts that are out there in video and in audio, that was Jocelyn right there coming up with her creativity. So Joseph and I met for the first time, and we nerded out on communicating technologies, right? We were just standing here, just introducing, we're just talking about technologies, and somehow we got on communicating, and it just went down this amazing like starship rabbit hole. Like we're like flying through the rabbit. Like I love rabbit holes. I love conversations about technologies and innovations. And this one really got deep. So it brought up the conversation of we should spend a little bit more time talking about the actual architecture behind communicating systems. We've had some conversations before with some other manufacturers talking about protocols that they use. A lot of it's been from a third person perspective. Well, we're actually going to be sitting down with first person perspective that has an engineering background as well. So not just the technical side, but the engineering side of things. So
Don't give away my secret.
Joseph, you want to give us a little bit of background in the industry and tell the audience a little bit about yourself?
Oh, sure. Thanks. Thanks again for having me on. So my name is Joseph Falk. I'm with Allied Air Enterprises. Like Clifton said, I am a technical trainer here. I've been with Allied and in the HVAC industry for about 13 years now. I actually came in and started as CAD designer, so doing all the modeling. And we were talking a little before the show, Jocelyn, too, about getting into it and learning things and seeing all the way down to the nuts and the bolts of how the stuff is put together and understanding the background there. Went into engineering, was with our engineering group, and then transitioned 2.5, almost 3 years ago to the training side. And this has been a blast. I think every day I come in, I'm very thankful for everybody that's in the industry, because this is one of the biggest spots that if you got a question, you ask it.
Yeah.
And
someone has an answer.
Someone is either going to have an answer, or when they don't have an answer, because we don't always.
Right.
When you don't have an answer, someone's going, well, that's stuck now. We had to go find it. And you talk about rules. And I think that this industry speaks true to my heart and my mind some days because of that. But yeah, it was great meeting up with you last month, like you talked about, and we were saying we talked for not long, but it seems like it was half a day, a conversation just like that deep and that intense in the topics and everything.
Yeah, I just absolutely appreciate the passion, and the passion for education and the passion for sharing education that you have is really the heart of what we do here. We work with a lot of educators. We also work with a lot of technicians. I see Osvaldo joining us from Belize. Osvaldo's here almost every week from Belize. Technician, just learning about what's going on. Garrett, that's really intriguing. Are you in class with your students? I hope so, because that's the goal of this show.
Yes.
We've always wanted to make sure that we've got our audience across the country, and if we can have it with our students, well, that's really the ideal scenario. We've even discussed, do we need to start looking at other times of the day to make sure that we can provide the show in the middle of school hours? So if that is something that all our educators that are with us, if that is something you have an interest in, let us know. Let me know in the chat or send me an email. Let's have that conversation, because now we have a lot more flexibility on how we can provide this content. And I would love to start showing up at some schools and having some of our students in the studio doing some hands-on. And that's really our goal. All right, so let's dive into it. Let's dive into communicating systems. We've got some content that we're going to go into, and then we've got some additional resources for you. So Joseph, let's start from a very high level, and let's talk about why we went from standard 24 volt AC thermostats to communicating.
Yeah, and that's something that I think is pretty cool to start and to think of is, what about just a standard set? You talk communicating, what's the difference? What actually is there? And if you break it down, kind of that transition into its kind of smaller buckets. And I think a lot of it can be the technology became available for equipment. You think inverter, you talk about the system that you've got, systems that are all across the industry with inverter and varying frequencies within the equipment, how it can get controlled, and then the efficiency. We more and more, there's a demand for efficiency. And so to drive it there, you have to look at how do we get there? Is it internal? In some cases, you could with internal to equipment, algorithms and programs. In other cases, it's like the thermostats. That becomes the brains, and it helps as the flow through. And I think that just as we get more and more technology that's available, we were talking about that a little bit earlier too, as these things become more common, it's how do we really dial it in? So efficiency, the change in technology, and even like with communicating and going from one to the other is something that I always like to try to focus on is the homeowner, the end user. What is the purpose of this for them? You could have it and say, I want cold when it's hot outside. I want cold inside. When it's cold outside, I want hot inside. And you want to say, okay, on, off. Well, there's systems for that. I want it to always be this temperature. Okay, now that's kind of demanding. So we've got to look at that more. And even to the fact of dehumidification, and very much dehumidification, indoor air quality. We know that there's lots of areas in the country that have minimum requirements for types of indoor air quality. And at a certain point, it becomes, well, we've got to have something to control it. And you've got to have this that talks to that. And communication is that right there. It is a two-way flow of things instead of just a standard 24 volt or whatnot thermostat that's, hey, send a signal on, cool, you're good, turn it off. We'll swim through the field there.
Yeah, no, really. If we think about a standard mechanical thermostat, right? That's the thermostat most of us have been used to for decades, over 100 years. And it's a combination of switches, right? We've got a switch for heating. We've got a switch for cooling. We've got a switch for fan. We may have additional stages, which are other switches. And we're getting to the point where we're starting to control a variety of different components, and we need to have more switches. So it's either I've got 30 wires running to my thermostat, or I need to come up with a better way of doing more work with less wires. And that's really the principle that we're going to get into. But when we get into that, things do change, because when we think about our previous generation of standard 24 volt AC thermostats, a switch would close, which meant a load would pass through that, and they would turn on things, turn off things. When we get into communicating, we're talking about sending signals. We're talking about sending code, right? Last week we talked about some of the pulse width modulation where we look at signals and I can talk. Think about Morse code, right? Morse code is a way for us to send a lot of data over a wire or two, right? So if we think about those commands, right, we're able to send some signal. Later, we moved into telephone where we're using those same couple of wires, and we just got faster at the way that we turned on and off the voltage. So when we look at communication, it's a different philosophy. It's a different architecture than our legacy thermostats. And so today we're going to spend time talking about what it looks like, how they communicate, and when we have problems, what can we do to try to solve that? So there's a lot of great information, and it's wonderful. Garrett, I am so glad you're doing this in your classroom. So Garrett does have his class starting here very shortly, and they're going to be watching us in the classroom. So this is fantastic.
Oh, that's so cool.
Yeah, this is going to be great. Thank you, Garrett. Garrett is at Ivy Tech here in India, and south of me in Bloomington, Indiana. Ivy Tech has quite a few HVAC campuses in the state of Indiana. All have went through HVAC Excellence accreditation in the last couple of years. So we're grateful to have you here with us, Garrett. And if any of your students have questions along the way, let us know. We would love to be able to address this to them individually. This is a really important topic. Now, I will say we're going to be going deep in the weeds with this one, right? So this one, some people are going to go, that is just more than what I wanted to know. And then some people are going to go, wow, I never looked at it from that perspective. And then there's others that are going to go, that's super cool. That's how we should be talking about this. So there's going to be a little something for everyone. So what do you think? We'll start in maybe some slides and we'll kind of talk our way through and then get really deep into the weeds with some of the other resource.
Yeah. We can start off and kind of give a direction. And then we'll switch from there, like you said. That'd be great.
Let's do that. So this is one of the classes that Joseph and the training and technical training team offers through Allied Air. So I encourage all of you to start looking at some of the classes. If you are a technician that works with Allied products, boy, they've got some fantastic classes for you and a lot of training and support. I was very impressed when we went to the conference. All right, so let me bring that up. I'll move us over to the side. How about I put us over here? And I'm going to remove names on this one too, real quick. Okay. Where are we going to begin?
Well, we'll just start off. So with Allied, when we talk communicating equipment, we have furnaces, air handlers, heat pump. We've got all-weather heat pump options as well. And this is just an overview of what our communicating system is.
Sure.
So we'll talk about this and then kind of phase away and get into the nitty-gritty of things, the fun stuff. But I wanted to kind of give the idea for our setup. So Comfort Sync A3 is our communicating thermostat. And if you look, we've got an HD display and a smart hub. And something that you talk communicating, and there's different ways of focusing in on it. Where is it process the information that's coming and going? And with ours, we have a display, and I call it the peripheral. So you think a desktop computer, your screen, your mouse, your keyboard.
Yep.
And the smart hub is your desktop computer. It's the box that sits to the side that is where everything is happening. So when you're going through and you're working, you are putting input through a peripheral into the system. And that's how our system works. So we've got a display. The display runs off of lower voltage, but still has communicating wires that go through it to the smart hub. Smart hub then goes to the indoor. And I've got some other slides that we can talk about types of wiring even.
Sure.
And how that can be affected. But really as a whole, just kind of that's where our product runs through with communicating. So you would have, say, an inverter heat pump, and then a full variable speed air handler. And this is where the programming comes from. So you're talking options for dehumidification and where you want those points to be at. It's not just a single relay closing and saying, send my signal.
Turn my AC or on or whatever. Right.
And then, hey, the temperature's hit, turn it off. It's, well, how close to that window do we need to be? How long do I need to run after dehumidification? What's the percentage of humidity I'm looking for? There's a lot of different aspects. And with that, a lot of it does go back to the comfort of wherever you're at, an apartment, a home, a condo, and being able to tap into the full potential of the equipment.
Yeah, absolutely. And Jocelyn, if you have any questions along the way, hop in here. Remember, we're going to have a lot of audience that this is new. And so a lot of the topics we cover are, fairly high level topics that we try to make them understandable for everyone. So don't be bashful in here. And Scott, yeah, we're going to be out on the road for a variety of different things. And I know one of my trips is going to be headed that direction. So let's definitely reconnect after here. I'd love to catch up with you.
Awesome. Well, if we want to kind of jump into it a little bit more,
let's do that.
Communication,
let's get right into it. How do we do it?
Yeah.
How do we make these communications happen? And what happens when they don't?
What happens when they do and then don't?
Yeah.
So we could sit and talk here for a bit and then come back if you want to.
Mm-hmm.
So with communication voltages, it's like you said, with Morse code, it's dots and lines, and in a sense, if you were to visually look at it. But for us, it's sending some form of electrical flow to and from the equipment. This is what it would like. So here's your switch turning on. This is what I would like from you. And it sends back going, I can do it. Or the internal algorithm may say there's going to be this much of a ramp, and then we'll go in and try to stage its way through.
Okay.
And when you get through that with any type of equipment, sometimes you have to look at it's the first time you've come across it, or there's certain things that start interfering. Well, where does that interference come from? Why am I having an interference? And looking at it not from the sense of, is there something wrong with the equipment, but what else is around me?
Yeah, what else could be causing this?
Yep. What else? You look around and you're taking an observation. And I've got some examples for like troubleshooting when you get started. I kind of call them the first steps, so your visuals. And we can go into that, or we can hang out and talk on.
Well, I think let's stay here just for a minute, because I want people to help. I want to help them understand what we're doing on these communicating systems, because many a time we are going to see a 4-wire connection. Mm-hmm. Sometimes we only see 2, but that's because we've already got power somewhere. And so many systems are coming out with communicating thermostats and communicating equipment, because we can do a lot more with it. Like when we talk about modulation, right? When we talk about ways that these units now step up and step down, whereas in the past it was either on or off, right? That was it. It was like you turn on a light switch and the light comes on, right? That was our traditional ACs and heat pumps. Versus today, it's kind of like having your dimmer, where you actually set, like how bright, how fast do we want this? Do we turn it down? But we need to be able to talk. But we also have to still think about that thermostat. Right? That thermostat still got a lot of lights on it. It's still got a lot of things happening. It's still probably connecting to Wi-Fi. So we still are running a steady supply of power to a thermostat. But then we also have our additional communication that's going on in that same bundle of wiring. And that's what is really going to help people understand what all of this is about. Hey, thanks for joining us from Boston. Appreciate it. All right, so let's look at this, because am I seeing indoor unit, outdoor unit? Where would I begin here?
So this is actually just a snippet of what you would see on the Smart Hub itself.
Okay.
So this is in between the display and the equipment. Mm-hmm. On the left side, you've got, like you said, you have 2 wires that's focusing on your power, your R and your C. You've got.
Now, is that 24 volts AC though?
The R and C would be at 24. Yeah. Okay. And then you've got an I plus and I minus.
Right.
So now we're talking, you've got a 24 and then your I plus and I minus. And that's, you're a few volts that you're talking about, not 24. 3.
And is that in DC?
Yeah.
Okay.
Yeah. So we're looking at this in the DC current. And when you pass through, you can see on the right side, we've got a plus, a minus, A, and a B. And at this point, we're actually changing things. Since it's going from the smart hub to the display, we look more at like a 12 volt side. So we've dropped the voltage, and with that, we're still using a 4-wire setup for it. So you've got your inputs going on. It's a touch screen, so getting your inputs from there, and you're all, like you said, you're powering a display. But it's, in a sense, think of it like, you're turning an old old style stat, or you're shifting over, tapping up, tapping down to adjust, and it's taking that, sending it to be processed, and says, from here I need my indoor system to do this, outdoor system to accommodate with it. They're going to work together and kind of have that handshake, and in tandem take that call through the signal from the display, low voltage, to the communicating side. And then you've just got the power that's flowing through it to give the controls the oomph, actually take and push the demand.
Sure. So if a technician is getting their meter out and they see 4 wires, and they put their meter on volts AC like they normally would, they're going to go from common to R, and they're going to read 24 volts AC and go, oh, okay, I've got power here. And then they might go to the positive and to the I positive or to the I negative and go, wait a minute, I don't have 24 volts here. Why not? And that's because we are actually going to be communicating. Think about like a modem line or a telephone line, where we're actually sending data back and forth. And that's what we're going to be doing. We're going to be sending a data line so that we can communicate on. Now, it's not like we can put our meter on and read the voltages and know exactly what's being said, but we can have an understanding of, do I have a clear path for communicating, or is there something interfering with my communication, causing things to maybe not talk properly, right? Right.
And even the interference, we've talked about, we talked some earlier, and I've had other conversations with people of even understanding the level of interference.
Exactly.
And how do we find out where, what other factors do you take in? Again, taking an observation of everything that's around in the home. You talk about external factors, even the type of power coming to. You've got solar with your setup that you've got, and even if you looked at like a generator setup, well, how is that coming out? Because generators have sine waves of their own that you have got to look at. So there's lots of levels of complexity, and we're talking with our equipment, but really that's any
communicating equipment,
any type of communication, or any form of flow. You talked like a mic and an amp earlier, and
Okay, great example. All right, ready for this, Jocelyn? Okay, so I thought I was going to be able to share this, but it's actually cleaning up our audio enough that you're not going to hear it on your side. I'll try to take some videos of it on my side so you can hear it. So I get the whole studio up and running, and I was originally concerned about, because it's not a fully grounded network, right? It's a mobile solar system. I don't have a ground rod going into the ground. So I'm like, okay, what's our ground frequencies going to look like? And so I get everything together, everything's functioning properly. And on my audio control, I've got a 4-channel mixer, so we got 4 separate mics here, 4 different Rode Pod mics. And I fire it up, and 2 of my mics are just as crystal clear as can be. And 2 of them have that that we've all heard before, right? The noise, the hum. And I start looking around and I go, oh man, what is going on here? And then I was like, wait a minute, we're talking about interference on communication lines today. Maybe this is a good opportunity for me to put this into practice. And so I started moving my wires around, and what I found was that those 2 microphones, the cable that came with them must not be very well insulated, and they were sitting right next to a transformer for the console itself. And that's where my interference was coming from. So if we think about that, just something like that transformer with wires that are not probably the correct wires to be using next to a transformer, I had interference on my communication. Think about that, right? We are sending voltages, our microphones, we're powering it up with a constant voltage. When we change the diaphragm, it changes the voltage and it sends back as a voice, right? As a sound. So we're traveling a signal, a voltage, a low voltage signal, just like we do with our communicating thermostat. Now, the discrepancy that I heard by being in an area next to a transformer, can that affect the way a communicating system runs? Right? That's what we're here to talk about today. And so that's one example. And we've actually got some good training on how that works. I've got another example I would like to share for you. Be thinking about both of these as we're going through this training. In my previous world, I was a technical support specialist for a distributor. I worked with a manufacturer to do a lot of site visits. We had one particular system. It was a communicating system. It worked great most of the time. Homeowner was having problems with it losing communication, and it would get an error code on the thermostat. Communication lost. Contact your contractor. Right? And so they got tired of seeing this, and they wanted new equipment. They thought their equipment was faulty. Because the rest of the time it ran great. So I pull up to the home, getting ready to evaluate what this potential problem with the equipment could be. And I'm walking up and I look up and I see about a 70-foot antenna tower in the backyard. And it's got little fingers coming off from it. I'm like, well, that's interesting. So I walk inside and we're having this conversation. Homeowner is he's very distraught. He's concerned because this brand new communicating system stops communicating. And I asked him, I said, well, have you seen any consistency to it? He said, yeah, every Monday I've got this signal. Every Monday morning I've got this on my thermostat when I walk through. And I go, okay, I'm curious. I see this big antenna in the backyard. Is that a ham radio? He says, yeah, it is a ham radio. I said, where's your receiver? He said, come on in, I'll show you. So we walk into the living room and he's got a picture window in the back of the house and his ham radio sitting in front of this beautiful picture window, right? Mm-hmm. And what's on the other side of the window? His communicating inverter 3 feet away from his ham radio receiver. And I pull out the installation manual for this particular one. It says, look, it actually says here in the installation manual that this communicating piece of equipment should be at least 60 inches away from any type of television, radio, any type of broadcasting equipment. I said, so how often do you use your ham radio? He says, well, I'm in a club and every Sunday night we have our meetings and we talk. And I'm like, well, every Sunday night you're throwing an error code on your system that's coming up on your communicating thermostat. And he's like, I don't understand how we do that. And so today we're going to walk through some of that. And I think it's quite interesting.
I love that example.
It was great.
Leave it to the guy with the ham radio.
Right. But how, right? How does it do that? And that's what we're here to do. Here on Did You Know, we dive into these questions. It's not, it's not just did you know, this is how, because we ask the questions and we find the right people in the industry with the answers. And Joseph's definitely got the answers with this one.
Yeah.
And if anyone has any questions along the way, had any experiences or unusual or bad experiences with communicating systems, let us know, because that's what we're here to do, is to help you understand those. All right, let's dive a little bit deeper.
Okay. All right. Well, so to your point there, the example that you had is a good stepping ground to go into kind of the next talk of troubleshooting it.
Yeah.
And
what happens when I have a problem?
Looking around and paying attention to what is around you and how you approach it. I use the example, like the first one we're talking about, if there's unused wires, we need 4. And in our case, we need 4. And especially when you're looking at the low voltage communication portion itself, it's the most susceptible. So how do you protect it? If you've got them, grouped together, or there's excess wires around, having a ground. You mentioned that yourself of where you're at. You don't have a ground rod dropped in, and everything. Actually, it sounds fantastic. I love the audio levels. Everything is really good, and the broadcast is clear. And I know you don't have a ground stake, but that means that something else has found a ground and
Right.
is acting as that source. So what we say is like, take your extras, land them back on the C, but the terminal strip of the equipment. So we're talking, we've got a 4-wire set for communicating, but on the equipment, there still is a standard terminal, your Y1, your W's, your C's, your R, and kind of taking the excess out of the path that we're communicating along and say, hey, drop that to ground in a solid set point here. That's a common ground that's got your indoor, and everything is run from that one. One of the other things is even just looking at the loose terminal connections and how tight is it? Do you have a good enough contact? And with that too, when you have, if you're using wire nuts, if you can solder it together, that's going to be the best way to have a definite connection. But if you're in the case of using wire nuts, or using dielectric grease to stay in there, keep anything out that's not supposed to be in there. And this one I always make the joke of, there's always the chance that a wire nut can become a wire knot, and there goes the whole system.
Yeah, that's perfect. That's actually one of the larger components of failures that I found in the industry. I always recommend running new thermostat wire if we can when we're doing an installation on a communicating system. But many times we can't. We're reusing the existing thermostat wire. And remember, that existing thermostat wire, you could have had corrosion inside of that wire nut, and because it was a load, it had current passing through it, and it might have worked. But when we talk about something that is communicating, very low voltage, very low amperage, now we actually have resistance on that communicating line because of our corrosion. So very first thing to do is cut any wire nuts out, make sure they're clean, fresh, new insulation on them.
Running new wire is not a bad thing, especially with communicating.
Absolutely.
The low voltage side. And if you are running the wire or paying attention to what's around, the fourth box that's on there is it's verifying the low voltage, and what other voltages are around it that may make it susceptible. Where's your high leg run to the indoor equipment? When you're running your solar panels, how close are you connecting? I've got, there's all sorts of examples you can use there of, you get solar put in, you had great internet signal, and next thing you know, everything's going through, they've got all powered on, and why is it that now in this corner of my house, even though I'm plugged in, or I could be on Wi-Fi, now I'm kind of losing it. And it's looking at, how was it routed? What else is it beside? Is it right beside your modem? Which again, low voltage communication portions there. So having the visual and taking the time of, well, are these together? Are they even, it depend on who the contractor is, how is it held and joined?
Sure.
And clustered. And then, like we've mentioned a couple of times already, is your grounding. And I've seen examples of your ground from here to there is together with electrical tape, and everybody winces when they walk into the area and go, oh, okay, well, I think I can fix this now.
Absolutely.
Yeah. And we can take it even further, and once we look at all of these, if we've determined we've got a solid connection point, we've checked our end connectors, that brings in, this is now a point to where we can go deep down a rabbit hole.
Yep.
And the insulation on the wire, is there insulation leakage, induction from a higher voltage, like we talked about, a crosstalk between similarly run and close proximity type of communication. And all of that goes to, are we somehow disrupting, degrading, distorting the lower voltage, the little guy? There's I'm a nerd, so the saying "there's always a bigger fish," and it's the same thing. The big fish can definitely overpower any of the little ones pretty quickly and pretty easily if there's not a safe place, which would be, a proper setup, having shielding if needed in some of the cases, or just separating power from communication and giving a distance between there.
Using separate wires actually for that.
Using actual separate wires, yeah.
All right. One of the things that we were talking about, which I think is really cool, is how can we get that interference from AC onto these little fish? Like, how do the big fish take over the little fish?
Yeah, it's an example that has worked. I usually have a visual that I throw with that one, but for this case, just that's old Star Wars references on that one. But with that, yeah, I mean, you think, okay, you may have your layout, you're running your cables, and or they've been laid out for you and you're there to do the connections. Things like if you had the cables, if they're stapled to the wall and something missed somewhere or it's clipped the edge. You mentioned it earlier too, of if it's older, especially in the attic, somewhere that's had a thermal cycling and it has degraded the covering or the existing, whether it's a shielding or just the standard cover. Sure. Now it's exposed. So with that exposed section, your higher voltage is naturally going to have some sort of emission coming off of it. So how much of that high voltage that's leaking out can go into a lower voltage, and where? So is it a portion of the wire? Is it, like we said, do you not have everything completely separated where it might actually need to be? And the proximity to those higher interference portions.
Actually, there is a really good picture in one of the resources we wanted to share with you today. It's called control.com. And I am going to share this other screen so we can kind of talk about that, because there's a really good reference in this. When we look at that exact thought, when we look at how do we bleed from one wire over to another, and that's really what we're doing. So let's talk a little bit about, we always have some of that capacitance in the air, but what happens if we have something crack or something break in that? It's going to cause some leakage into those lower voltage wires, right? Help us walk through a little bit of this representation.
Yeah, so looking at this one, this gives the image that I was trying to say, talking about the bigger fish. So we've got on the top, it looks like it's the power source. So with the power source, that's your higher voltage. Mm-hmm. So that's your larger portion, a 240 or whatever it may be in that sense. And around it, it has a natural magnetic field. And, there's always some sort of leak, like we said. And below it, if we reference that as our communication, so now this is our lower voltage format for sending signals. If you start getting that leakage from the magnetic field onto the lower voltage section that's there, you've now started to block potentially. And I always talk about like if you are hooking it up, you're looking out on DC and you're looking for the signal wave going in and actually cutting it or causing enough of an interference from that larger force to drag down or completely disrupt the lower one. So top would be your high voltage, bottom is your low voltage, and we're literally casting out little bubble in it. And when you start having some sort of if it's a crack in the wiring or a not properly grounded shielded setup, is it allowing something to leak in and just travel with the whole system there? That's a solid example and a good visual reference of just leaking over into the little guy.
Do you have that slide that shows the sine wave where we're actually disturbing the sine wave, the signal for the DC?
I don't have that one.
Okay. Or is that one available in this by chance?
It's probably on there. Yes.
All right. Because I think it's very intriguing. Oh, there we go. There we go. Okay. So that was the difference between analog and digital, but I think it is a really, really cool reference when we're talking about how we can disturb that signal. Tell us a little bit about that difference between analog and digital and how that disruption can affect our signal.
Yeah, so when you're talking on the communicating level, especially, you focus on the digital side. With digital sense, you have more forgiveness.
Mm-hmm.
I would put it that way. This gives a good visual for on the analog portion. You've got to stay pretty constant to go straight through. And on the digital side, you've got portions and you can catch these bits and bytes of it, and it will naturally flow. And, oh, this is here and I'm going to go to here. Well, like you see, if you get enough of that field that comes in on the lower voltage or anything else that might be something that's generated along the path, you can start corrupting a portion of it, and you're not able to hit the highs and the lows and you could almost look at this like the sine wave, like we were saying,
Mm-hmm.
and not be able to keep the high and the low separated from the big high and the big low. And with the digital side, again, you want it to run smoother. It's able to calculate more in there. One of the things that we've talked about in some of our classes is that on the communicating side, and with technology where it is now, you can, in a sense, almost program out certain bits of interference. And if you know exactly what it is, take that into calculation. And it's like you were talking about with the microphone. You get some sort of a distortion in there. You know that there's some sort of interference. If you're in an area that's got a lot of reverb, turn down your reverb to bring it back in for my acoustically minded friends.
Sure, absolutely.
And understanding, okay, you don't need to add more to it, but you're still wanting to go from point A to point B. And this visual works really well because analog is a straight shot. Now, if you had some sort of interruption in there, a cut cable, what's going to happen? You lose the signal. I think about, old rotary phone on the wall.
Sure.
Pick it up. Hey, how's it going? Da, da, da. Someone comes over, trips over the cord. There goes the cord. There goes your connection. You plug it back in. You've lost the connection, especially when it comes out of the wall.
Right. It's already gone.
It's gone. It's ended. Boom. There's your analog. When you talk on the digital side for it, you get bits of the corruption in there, and it's like having your screen as it's slowly kind of, it's distorted. It's not fully through. It's trying to
reestablish connection.
And when you don't have that constant line of connection, that's when you can have things like an interrupted signal. And so it may think, oh, well, something happened and did I lose power to one of the components in the whole system itself? Talking on the HVAC side, or even a grander scale like controls. We're in the R&D lab for Allied. I'm actually upstairs in the studio, but out in the lab, we've got large cabinets with all of the controls that are flowing through. And I mean, you've got small voltage, high voltage, it's all separated out. And if you get to the point where you start losing a signal and it's inconsistent, we get a flag of, something's not right here. Stop whatever test is running. We need to go back and check that. And it's the redundancy of, we know it should be going nice and smooth, and now we're losing bits. Okay, something's not right. And the same way, like I said, going all the way back to with HVAC, with the equipment, of understanding, okay, are we losing connection, or is it down to a poor connection to the equipment itself,
Sure.
because of the wire that's come loose, or is it because there's some sort of interference, a cut wire or a stronger field? And we need to come back and look at, well, what wire is actually being run there too.
So where does our voltage start at? So we're teaching a student, we're teaching a technician to start diagnosing a communicating system. Where does our voltage, that DC voltage, begin?
So like I was talking about when we say with the running it back to the C on the terminal strip. So if you
Sure.
think about where the equipment is, so you could look at it and say, I am wiring from my outdoor equipment to the indoor equipment to the communicating thermostat,
Sure.
or the controller. So in that case, it would be pulling from somewhere on the indoor side. And so you can say, okay, my L1, my L2 is running to an air handler, and we're converting it down to the signals that we need, to the power that we need from there.
So with the Allied Air equipment, are there tests that we can do for voltage to be able to start looking for proper bandwidth, I guess I would call it, for our communication to be successful?
Yeah, and there's tell you what, we'll jump right into that one, won't we? So if we keep looking at the connections themselves, there's kind of three things that we can walk through, of starting off with the wires themselves. So again, looking at everything around, we think we're good. We think we've got good connections. You can't see through the walls, so you don't know what's happening between point A and point B all the time. There could be other things in the way. So what you do, some of the tests that you start off with is, taking everything out of the system, power
Disconnect.
included, and you're just looking at the wire itself. And if we look at the wire and ground, well, are we getting anything off of that wire? I'll go through that in a second, but how much inductive voltage is that wire reading? I use the example of, the rabbit ears on the TV, and that you got rabbit ears sticking up, and it's pulling in the signal.
Right.
Well, I don't want that signal. I want what's coming straight through cable, and not the external, that second source. So how do we look at, and what are the levels? Something else that you can look at too is when you actually have voltage on, how much voltage is going through. Are we having any loss? Is it fluctuating along the way? You can tell a lot from a system if you're looking at the power to it and how much it's fluctuating. That's something that, like with the inverter equipment that we've got, we have different levels of looking at, here's our high and our low for the voltage, and taking in a corrective action if the voltage goes too low or too high, because is it a surge, is it brownout, a blackout, something that's happened, and trying to protect it. So in the same way, you could sit, and if you start reading on the system, are we jumping drastically in our voltage? And then lastly, also looking at it with just looking straight from, again, ground to the wire without any power, and where is that? So in that case, then you can help diagnose, is it a component that might be the problem there?
Right.
If I'm looking all the way on the indoor side and I'm checking here and I'm not getting anything, well, I should, because I'm at the indoor. So do I have proper power coming in? Am I looking at, in our case, the hub that's in the middle? Or I'm looking all the way down at the display. Is there something that's not reading the to or the from direction.
And I can do that by reading DC voltages.
Well, so we can actually, here, we'll keep going.
Yeah, we've got about 5 minutes or so left in the show.
Yeah. So if you look at the AC, because
Okay.
the AC a lot of the times is what DC is where we're communicating on, and it's the AC that a lot of times you'll have as the leak, and that's where you can see, like I was mentioning, this is the case of we've taken everything off and we're just looking at the wires themselves. We're looking at an inductive voltage, so meters, volts, AC. We're checking one end, nothing else connected anywhere, just checking that one end. And the rabbit ears, the receiver, the ham radio, what we're now looking at this one wire. Is there anything else that's bringing in a field that's then captured in that wire and distributed? So in a sense, it's grabbing a signal. It's just the wrong signal.
Wrong signal, you bet.
Right. And so you can almost break it down even further of how much of a signal, because everything's got, there's naturally, like you showed in the diagram, there's naturally conduction that happens around. There's, depending on what you're around and how good grounds are, you could pick it up like a microphone you're walking around and to your point, if you have a bad ground in the wall, even, you can almost catch that when you walk close to some of the outlets. So in this case, you can take a lower voltage, read the interference from it. Is it 0.3 to a 3? That's not
So
bad.
you're going directly bare wire, bare thermostat wire, everything disconnected. Are you going from common ground to each one of those wires?
Yes, you can go from your C to the wire itself. Yeah.
Okay.
Yeah. And then as you can see, as it goes up, you get a 0.7. Well, that could be starting to cause an issue.
Right.
You get more than that, you're a volt or a 1.2 or higher. If you're higher than that, then there's definitely there's something nearby.
Periodic problems.
Right. Especially when you're losing connection, something goes out along the way, display from the smart hub itself or the hub to the indoor. Because in some of the cases you're only having a few volts travel around there. So 3 volts going through that's trying to communicate. Like you said, we don't know what's being said, but we know that there is this lines and dash like the Morse code that's going through. 3 volts, and if you're having a 1 and change volt connection that's coming in on it, 30% is being taken over by some sort of external force. And so what you're doing is, if you looked at the graph you had too, of you're starting to corrupt it, you're talking about you've now got a large corruption that's happening somewhere along the line. Now we found, okay, we've got an issue with our wires. So now you're going to be going down the rabbit hole of, are we running new wires now?
Yeah. I have never had anyone mention just measuring inductive voltage on the thermostat wires before. It's brilliant. I mean, absolutely. Many times it's, stapled right next to a high voltage line on the stud.
Mm-hmm.
And so any staples, any breaks in that wire, we could potentially be picking up inductive voltage on that DC signal. So we're literally just taking our thermostat wires and going from common or ground to each one of the wires and see if we're measuring the voltage that's being induced by AC lines, outlets, switches, everything.
Yeah. And
I can't wait to do that now.
I was going to say, there's folks that are in the classroom that can lay some wire on the table and
there you go, Garrett.
Try to check it out. There you go.
Absolutely.
Stick it near the window, put it in the middle of the class. You're under a projector, and it's just a natural occurrence. Now everybody's going to be walking around with a
oh, buddy, that's the next video right there.
Yeah.
How much induction do I have in this non-grounded studio here? All right. So what about the communicating voltages? We've got a little bit of time left on the Allied products. What is the best way to actually test for the voltages to see if we have appropriate voltage?
Right. So, and this is from our our manuals. I'm not reinventing the wheel or anything. I'm not taking credit
Sure.
on that one. But if you go through what we talked about before, baseline, eluded, landed, the different ways of reading. So actually looking at different parts, at the hub to the communication terminals of the indoor, from the display, from the equipment itself, and breaking it down. And if you look like on the baseline side, a lot of times a very low voltage that we would read, and this would be in a connected system, and then even your 12 volts, is it bumping it down correctly from your higher voltage to a 12 volt section? We talk about how good, what's your reading off your transformer.
Right.
If somebody says I'm reading 24 volts, then that might be the problem, because when do you ever see exactly 24 volts?
Exactly.
And so that's a very common thing. So looking at it and understanding, these are just examples. These are just a general throw to talk to. But looking in our meters, if we talk about how much fluctuation. So if you were to just put your meter on, you haven't disconnected everything. Well, how far is that fluctuation? Is it in the tenths, hundredths? Like how much of a fluctuation are we seeing? So you could see it again live and running. And then from that point, if you've got other factors, a dehumidifier that's in the system, is there something else like you were talking about with the ham radio? Well, start energizing those other systems and keep taking your readings and seeing, do we have, now we've got those big jumps in distortion. So my wire may be fine, but how it's routed could be the issue. And when that big piece of whatever accessory comes on, it seeps in. In that case, then we could jump into, well, how is it wired itself? So a good example, like we talked about, separating your communicating from your power. One that's probably the top way that we recommend running, especially with our 4-wire setup. Looking at it, you can have 4 together. People have luck with that as well. Sometimes you do have to break it all the way down to actually shielded. I mean, we can go into a whole other discussion just on.
Yeah, I think we may have to do a class on shielded wiring.
There, and talking about landing, a lot of what people forget is that you have to tie the shielded line and drop it on the common, drop it on the ground, and only one. You don't do both ends, because think of it like a tube and what's
creates like an antenna
through it.
Right.
And you want it to not be an antenna. You want it to block everything out, be in its nice safe little bubble. And if you then were to ground both ends of it, well, now you've created an internal amplifier. So you've almost made it worse inside than it was before. And also, we did talk about if you had multiple wires and making sure you send it and put it back on the common. So you can't always help what's in the wall.
Right.
Older houses, depending on what's there, and you get multiple wires that go in. But understanding, I gave the rabbit ear thing of, you've got both ends, they're both exposed, you're not doing anything about it. All you're doing is allowing any external potential inductive force to come in and flow right along those 4 wires you're actually using of this. So making sure you're capping them, having good wire nuts if that's the route you're going with, dielectric, and making sure that's in there. But connecting them together and having one source that then runs back to
common or ground.
Right. And so in a sense, you're grounding it. You're saying, I know there's something here. Let me grab all of it and we're going to direct it away. And a lot of what we say is, if you can put on the main terminal strip, take it out of the communicating portion with the four wires. You've now taken and said, yes, there's an induction, there's something coming in, let's grab a hold of it and just send it that way, further away from the main communication itself.
Love it. Fantastic conversation. Like I said, it was a deep dive into communicating. A lot of people don't understand what happens and what is the problem, where do we even begin? So I think we can actually do a whole nother one just on proper wiring, shielded wiring, proper grounding. Where can we learn more about any training classes and products with Allied Air?
Well, yeah, thanks. So with Allied, we have distributors, so you could contact your local distributor, Armstrong, Aries, Concord, Duquesne. We have Allied Commercial, and Magic Pack. So with those, if you find a local distributor, they can get you connected with either your local distributor service rep or DSR, like you were talking about our conference. And we've also got the academy where our training is. We have a trial window. Again, you can sign up through your distributor or alliedAiracademy.com. Lots of information. We focus that towards the service reps. And so if there's something that you feel like you need help with, find someone that you can reach out to in your area. Even if you had to call in, they can help you find your local distributor and get more information from them.
Fantastic. Joseph, I really appreciate it. Anyone in the audience have any questions? Jocelyn, anything of curiosity or questions that you have along the way? You're always welcome to throw them in there. I know that it's a lot, and this is probably not the best place for us to introduce you to HVAC. This is like deep into the weeds, but it is really good. It's one of the common things that we encounter as technicians, as contractors. There are many struggles with finding like what happens when this thing is not operating. Is it the unit? And we have contractors that will start replacing parts, hoping that they're finding the problem by replacing parts and replacing parts and replacing parts, not knowing how to actually look for a communication problem.
Proper diagnostics.
All right. Well, we're so grateful that everyone joined us and hung in for today. We're going to continue our conversations week after week. I should be broadcasting every week from the studio now. Next week, we're going to be heading over to Hudson Technologies. We're going to take a look at the reclamation process. We're going to be doing some really cool behind the scenes videos. We're going to have a lot of things to share with you. Jocelyn and I just came back from Carrier. We got to do some behind the scenes video at Carrier. So we're starting to have manufacturers like Allied Air joining in this training effort, given the industry all of the training resources that they need, making sure that you're getting firsthand information. I'm so excited to be working with Allied. I can't wait to come see an Allied factory in the future and look forward to the next DSR. I'm looking forward to it. So I told Jocelyn, this is the thing. This is what we will be doing, is bringing a high-end education to our industry. So thank you all so much for joining us.